What I want to do in this video is graph a classic exponential function and then graph a related logarithmic function and see how the two are related visually. And the two things I'm going to graph are that y is equal to 2 to the x power and y is equal to the log base 2 of x. And I encourage you to pause the video, make a table for each of them, and try to graph them on the same graph paper and see how they are related. And if you see how they're related, think about why they are related that way. So let's first start with y equals 2 to the x power. So I'll make a little table here, different x values and the corresponding y values. So x and y, we could start with -2, -1, 0, 1, 2, 3. So in each case, y is going to be 2 raised to this power. So 2 to the -2 power is going to be 1/4. 2 to the -1 power is 1/2. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. So let's graph that. So 2 to the third power is 8. 2 to the fourth, 2 to the 2 to the 2 to the third power is 8. 2 to the second power is 4. 2 to the first power is 2. 2 to the 0th power is 1. 2 to the -1 power is 1/2. 2 to the -2 power is 1/4. We could even do 2 to the -3rd power is going to be 1/8. So it's going to look something like this. So the graph is going to look, something like this right over here. And it's kind of your classic, sometimes this will be called your exponential hockey stick, because it kind of looks like a hockey stick, where it just kind of starts kind of slow and just bam, shoots straight up. And notice, as we go to the left, as x becomes more and more and more negative, our value approaches 0, but never quite gets there. If we have 2 to the -1/1,000,000th power, it's going to be a very, very small number, very, very close to 0, but it's not going to be quite 0. So we're going to have a horizontal asymptote at x, or at y is equal to 0, or the x-axis is a horizontal asymptote. Fair enough. Now let's graph y is equal to log base 2 of x. And before I graph that, let's just think about another way of representing it. This literally says for any x, what exponent y would, if I raise 2 to that, would give me x. So this is an equivalent statement as saying 2 to the y power is equal to x. And if you notice what we've done here between these two things, you're essentially just switching the x's and the y's. Here's 2 to the x power is equal to y. Here's 2 to the y power is equal to x. So really this and this, you've swapped the x's and the y's. So you've swapped the x's and the y's, and what we will see is that we could essentially swap these two columns. So x and y. So let me just do 1/4, 1/2, 1, 1, 2, 4, and 8. 2, 4, and 8. So here now we're saying if x is 1/4, what power do we have to raise 2 to get to 1/4? We have to raise it to the -2 power. 2 to the -1 power is equal to 1/2. 2 to the 0 power is equal to 1. 2 to the first power is equal to 2. 2 to the second power is equal to 4. 2 to the third power is equal to 8. Notice, all we did is we essentially swapped these two columns. And so let's graph this. When x is equal to 1/4, y is equal to -2. When x is 1/2, y is equal to -1. Y is equal to -1. When x is 1, y is 0. When x is 2, y is 1. When x is 4, y is 2. When x is 8, y is 3. So it's going to look like this. So notice, I think you might already be seeing a pattern right over here. These two graphs are essentially the reflections of each other. And what would you have to reflect about to get these two? Well, you'd have to reflect about y is equal to x. So if you swap the x's and the y's, so another way of thinking about it, if you swap the axis, you would get the other graph, which is essentially what we're doing. Notice it's symmetric about that line. And that's because these are essentially the inverse functions of each other. One way to think about it is we swapped the x's and y's. Just as this, as x becomes more and more negative, you see y approaching 0. Here you see as y is becoming more and more negative, as y is getting more and more negative, x is approaching 0. Or you could say as x approaches 0, y becomes more and more negative. So the whole point of this is just to give you an appreciation for the relationship between an exponential function and a logarithmic function. They're essentially inverses of each other, and you see that in their graphs. They're reflections of each other about the line y is equal to x.